Welcome to this webcast hosted by the Norway's Polytechnic Society and the Norwegian CCUS organization. My name is Jørg Aarnes and I'll be the moderator for this session. I'm joined today by three panelists, Stefania Gardarsdottir from SINTEF, David Grainger from Equinor, and Olav Øye from Bellona. We will be debating the role that blue hydrogen can have as part of reaching climate targets in alignment with the Paris Accord. But before we start, let's do some quick introductions. Let's start with you, Stefania, and then follow the order on the screen. Stefania, can you please introduce yourself quickly?
Yes, my name is Stefania Gardarsdottir, and I am a research manager here with SINTEF Energi Research. And I worked quite a bit with hydrogen and CCS in the past, let's say, 10 years or so. And I'm one of the co-leaders of SINTEF Strategic Initiative on Hydrogen. So that's my background.
Thank you, Stefania. David?
Thanks. Good morning. David Grainger. I am an advisor in Equinor. I work in low-carbon value chains, which means that I focus on hydrogen and carbon capture.
Thank you, David. And finally, Olav.
My name is Olav Øye. I work for the environmental NGO, the Bellona Foundation. And here I work with industry and climate solution, including hydrogen and CCS.
Thank you all. I'm looking forward to hearing your perspectives on this issue. Your diverse affiliations should set the stage for an interesting discussion. But before we get started, I thought I'd start with some reflections based on our findings in our recent energy transition outlook that was launched last week. This is a model-based forecast of how the energy transition will unfold based on current market forces and policies being set and how that will unfold over the next few decades. What we are seeing is that on the positive side, we're seeing that the peak emissions was brought forward 5 years by the pandemic. So we do not see that the emissions will never be as high as they were in 2019. But on the downside, we're seeing that the emission reductions are going too slow and that by 2030 we'll only have reduced the emissions by 9% compared to 2019. And in 2050, the reduction will be 45%. So we will be exhausting the 1.5 degree budget in 2029 and the 2.2 degree budget in 2053. But hydrogen is recognized to be a very key component of decarbonization efforts, both hydrogen and hydrogen derivatives. So we'll go a little bit more into that. Our analysis finds that hydrogen will, however, not be competitive with globally versus incumbent technologies until the 2040s. We also see that much more hydrogen and e-fuels will be needed in hard-to-abate sectors. We do see it playing a particular role in both the maritime sector and also in the aviation sector in the 2040s. Over time, we see that green hydrogen will gradually take over and dominate, be the dominant production method. But we also note, which is part of the discussion today, that decarbonization of gas is slow. So given this outlook, the two key questions that we're raising here today is, what role do we see that blue hydrogen will play as part of decarbonization efforts? And actually, how friendly or how climate friendly is blue hydrogen? This gives an outlook of the scale of hydrogen production going forward. You can see that bottom two wedges is basically reflecting the existing production of hydrogen from natural gas and from coal, and only about a percentage point of that production is today decarbonized. In 2050, we see on the positive side that the production method will be dominantly decarbonized, and blue hydrogen will be representing about a quarter of the decarbonized fraction. We also see that blue hydrogen will have a particularly important role in the early days, whereas post-2040 we see that the most of the additional production will come from electrolysis, and then particularly from electrolysis of renewable power. But if you take and zoom out a little bit and think of blue hydrogen as a way to decarbonize gas, So what is the picture that we're looking at in terms of the role of blue hydrogen as a decarbonization vector? This picture indicates the amount of gas that is decarbonized. This graph shows the supply of natural gas from today towards 2050. And we see that the gas supply will be remaining at a relatively constant level. We do see that decarbonized gas is making its entrance post-2030, but even in 2050, only about 15% of natural gas is being decarbonized, either through the use of biomethane or through the use of blue hydrogen. So that is basically setting the stage for today's discussion, and I'm looking forward to getting the views from my panelists on how we can sort of deal with this issue. And I'm first going to give the floor to David Grainger from Equinor, who will provide some perspectives on this. So over to you, David.
Sure. So Equinor's ambition is to be a net zero company by 2050. So net zero means with regards to our own operations, but also our products and how our products are used. And this is going to be achieved by a number of ways. So the first is a gradual decline in oil and gas production. The other is a massive rollout of renewable capacity. The third is decarbonizing our own operations. And then, of course, CCS. So CCS is essential. It's going to play a large role. And it has, I think, three main roles. So the first is we can use it to reduce emissions in our own operations. So, for example, we do it in Sleipner and Snøhvit. So the second way CCS is important is that it can be used to decarbonize our products. So one example is flexible gas power plants with CCS, post-combustion. And then, of course, the production of low-carbon hydrogen. And it's important to say that we in Equinor, we don't favor blue hydrogen or green hydrogen from renewables. We want to deliver both. Okay. And then the third way CCS is important is as a service that we can provide to other industries which are hard to abate by electrification and that need a place to store CO2 safely. So that's the third main aspect. And then if we look further down the road, to achieve net zero, you're going to need negative emissions. In other words, removing CO2 from the atmosphere. And bioenergy with CCS is one way to do that. Direct air capture is another way to do that. And for those, you also need a transport and storage network. So yeah, so CCS is crucial to our strategy.
Very good, David. It's inspiring to see the ambitions that Equinor has been put forward, and I also think that Equinor has been a leader in many ways in the CCUS space. And you are indeed a major gas producer, and you have significant ambitions for greenhouse gas emission reductions towards 2030 and 2050. But can you also explain to the listeners a little bit about the key points in your climate strategy and what kind of role that you see that CCS and hydrogen will play in that strategy going forward towards 2050?
Yeah, so we do have ambitious, we have bold ambitions. So you see here that we have said that by 2035, we aim to capture and store 15 to 30 million tons of CO2 per year, which would give us more than 25% of the market, or expected market. And we also intend to supply hydrogen in between 3 and 5 clusters, industrial clusters around Europe, including Norway. And this would give us more than 10% of the expected market. But the prognosis that you show in the ETO, it's similar to something that we have in our energy perspectives, which is called the reform scenario, where basically if you look at the current trends in market development, in technology development, and most importantly in policy development, things don't happen fast enough. And there isn't this deep deployment of CCS and hydrogen. So it's disappointing. If you look at what's needed, to remain within 1.5 degrees Celsius, I mean, the prognosis is 150 million tons of hydrogen production per year, and about 500 million tons of hydrogen total, including green and other types. So it's a big difference, but even if your prognosis is correct, that's 50 million tons of hydrogen per year. And that's a vast amount. So if you look at the projects that we have planned, if we take let's say the flagship, it's in the UK, where we would produce in the first plant around 130,000 tons per year, right? So we'd need hundreds of such plants to meet 50 million tons, let alone 150 million tons. But what these show is that if the policy isn't in place, you don't get this large-scale deployment of CCS. So that's the first thing that has to be in place, widespread and strong policies, incentives, CO2 taxes that have meaning. And the other aspect is that we have to decrease the cost of production of hydrogen, especially green. And we need to get the cost of CCS down. And then I think the last thing that we should emphasize is there's so much talk about production. How are we going to produce so much? Should it be blue or green? I don't think there's enough focus on the users. The users are also somewhat immature, both technically and also commercially. So we need to have more support for them, business models, because if the customers are there, then the producers of hydrogen will invest. Yeah.
Thanks, a lot of good points there, David. So the policies need to be in place. We need to bring down the cost, and we need to strengthen our ambitions in order to reach the climate targets. You've put forward quite ambitious targets. I mean, the 15 to 30 million tons of CO2 capture per year, that's on an equity basis. So if you're looking at that on a sort of amount of CO2 that is stored, I think you're talking about some 70 million tons. So that is certainly bringing us in the right direction. Before I sort of hand over to the next speaker, I just wanted to see if you can start to reflect a little bit on the sort of decarbonization of gas. I did point to that sort of picture where we're looking at only a small fraction of gas being decarbonized. And if we're meeting the Paris Agreement Accord targets, we need to change that picture as well. So do you have any sort of comments to that before we go forward?
I think, as I said, it's policy that's really lacking in these let's say scenarios like reform and ETO. So having the strong policy, having the incentives in place, and at the same time reducing the cost of hydrogen and CCS so that it's palatable for societies to pay for. Yeah.
Thanks. I would say that I agree. Policies are important. Carbon price is important. If you see that also escalating, then we'll see also different trajectories. But with that, I think we'll go into a little bit about the facts behind the science here. And for that, I'd like to bring on board Stefania. So I'd like to see Trondheim. Can you hear us?
Yes, I can.
Very good. So Stefania, you are leading strategic initiatives at Hydrogen in SINTEF. And the key question we're asking today is how climate friendly is blue hydrogen, or perhaps more precisely, what does it take for blue hydrogen to be a low carbon energy vector that can deliver on our climate targets? Can you break this down for us?
Yes, let me try. And if you maybe show my first slide, I couldn't help but be a little bit tempted to put forward a little bit of a different scenario than what was presented in the DNV report. And just to kind of give a little bit of a different perspective on what could be the potential role of hydrogen in decarbonizing our energy system. And recently, the Hydrogen for Europe study presented their final report, and this is a figure from that report that I said I just couldn't help myself to put that forward there. So this report presented an analysis of the European energy transition. So this is only from a European perspective then, and looked into details on what could be the potential contribution of both renewable and low carbon hydrogen in this transition, so both blue and green. And this study then rather poses the question on what is required of us if the ultimate goal is to reach carbon neutrality in 2050 and also comply with the 2030 goals of reducing our emissions by 55% compared to 1990. And without going into too much detail, so this study explored basically two different pathways. And one of them is shown to the left there, the technology diversification pathway, which basically puts forward a neutral technology perspective. You basically use all the technologies that are available to reduce your emissions. While the pathway to the right, which is called the renewable push, then more focuses towards like a deliberate focus on renewable technologies to reach our climate targets. And basically here, so in both of these pathways, energy efficiency and electrification, of course, play a very big role in reaching our ambitions or our targets. But there is quite high competition for renewables when you're building out new renewable capacity to decarbonize many sectors. And that means both power, transport, residential, and industry as well. And this will take a lot of time to build out such massive capacity. And so that's where we see where hydrogen can actually have a complementary role, and a significant role, and a very complementary in those sectors where you cannot deeply electrify, or energy efficiency measure can only get you so far. So with that said, I think I would just like to kind of point out the complementarity in between the blue and the green, because that is this kind of a discussion that is always going on in a sense. And I think that also, as David kind of mentioned, shifts the focus in the wrong direction. It should rather be on how to actually get the uptake of hydrogen in the end user perspective. But in any case, we saw that the blue and the green complement each other, and the blue hydrogen will have quite an important role in this transition or first period to kind of start build out the infrastructure for hydrogen, while gradually, you can get more and more renewable capacity to produce green hydrogen that will eventually take over in the long run and kind of supply the market with the most of the demand. And yeah, so I just couldn't help myself to kind of bring up this bit of a different perspective and more pose the question, like, what is really required if we want to get to net zero? And with that, maybe we can look at the more on the climate footprint of hydrogen, and blue hydrogen especially, and kind of what is then required for blue hydrogen to be this viable tool, so to say, in fighting emissions, and actually being an effective emission reduction tool. So what this picture shows here is basically how the CO2 footprint of hydrogen is impacted by a specific factor, which is here called upstream CO2 emissions. And I will explain a little bit more around this. And then this kind of shows what is then required for hydrogen to be complying with the EU sustainable taxonomy, which is the golden line there, horizontal line there. And there are several factors that impact the CO2 footprint of hydrogen, of blue hydrogen in particular here. And one of them is then the rate of which CO2 is captured from the production process itself. And the second, maybe a big factor, is the so-called upstream emissions from actually producing the natural gas that is to be converted to clean hydrogen. And this basically means like all the emissions that are stemming from extracting the gas from the fields, emission that comes from powering all the equipment, turbines, pumps, and so forth that are required to produce the gas. Emissions from flaring gas, use of diesel in different operations around production, and then also an important factor which is highly discussed, which is the methane emissions. And methane emissions, they can, for example, stem from venting or flaring gases, also from plugged and abandoned wells. So this is quite an important factor. And maybe to first tackle this CO2 capture rate, which is also sometimes discussed. And this is not really an issue as I see it, because if you have a state-of-the-art process for producing your hydrogen, you can very well design your process so that it reaches like up to 95% capture rate without any issues. So I think this factor is basically not really so interesting to discuss. But what is trickier is those emissions that are stemming from the natural gas production itself, which are then depicted there on the x-axis in this figure. And here methane is really an important factor of the equation. And methane, it's a very potent greenhouse gas. It's way more powerful than CO2, even though it stays in the atmosphere for a shorter time. But when you're converting methane to CO2 equivalent, which is the unit of measure that we use for these kind of calculations here, you have to multiply by 25. So this means that for every increase in methane emissions that you have from your production, you can get quite a hefty impact on the footprint of your product, which is in our case blue hydrogen. And I just put forward a few examples to kind of show where we have different types of productions and how they comply with EU sustainable taxonomy. So here in Norway, the methane emissions are relatively low. They are around 0.03% of the kind of total volume of marketed gas. So only about 0.03% of this gas is then emitted as methane in the whole production process or the value chain. And this is around 5% of the equivalent CO2 emissions on the Norwegian continental shelf. And then Norway also has quite low emissions for other, let's say, other operations in the value chain, little flaring, increased electrification, and so forth. So for a typical, let's say, Norwegian blue hydrogen, you might end up with about 1 kilogram of CO2 per kilogram of hydrogen. So pretty low and complies well within the EU sustainable taxonomy. So that is the light blue dot there furthest to the left. But it's also interesting to take an example of the global average, which is the kind of medium blue dot in the middle there. And there you have quite higher methane emissions, around 0.23. But that still gives you, or you still comply with the EU sustainable taxonomy if you take that example. But in any case, as I mentioned earlier, so methane is a way more potent greenhouse gas than CO2. And even what you might think might be a small increase in the methane emissions will very heftily impact your footprint, the total CO2 footprint. So if you're in a, let's say, a field or a platform that has difficult situations or poor production methods or who knows what, you might very easily fall over this golden line here. So this kind of emphasizes the need to have very tight monitoring and have a proper documentation of your methane slip to be able to show and ensure that your product is feasible and complying with the targets. So I think that maybe that was a little bit of an insight on the climate footprint of blue hydrogen from my side.
Thank you so much for enlightening us, Stefania, and sharing your insights. I will also ask you to comment on this, David, but just let me first summarize some of the key points that you mentioned. You are pointing to the fact that there is a gap between, let's say, a business usual scenario in terms of how much hydrogen we are looking to produce and what was actually needed to deliver on climate targets, which is what you presented. You indicated that hydrogen will be essential in order to decarbonize hard-to-abate sectors that are difficult to electrify. You also pointed to the role of blue hydrogen as an important part of establishing the necessary infrastructure to enable that type of scaling of hydrogen. And on this carbon footprint, you're pointing to two important things. First of all, with the gas production, and if you're using state-of-the-art CO2 capture technology, you can easily meet the targets that are being set, for instance, under the EU sustainable taxonomy, where they're setting the threshold on the life cycle emissions of the hydrogen production. And you're also pointing to the importance of being able to control methane emissions as part of that value chain. And in that sense, Norway has actually a competitive advantage compared to basically all other countries in the world. But before I'm going to give the floor to you to comment, David, I would like to bring on board you as well, Olav. And you're representing Bellona. And on Bellona's website, we can read that the Bellona Foundation is an independent, non-profit organization that aims to fight the climate challenges by identifying and implementing sustainable environmental solutions. So that brings me to the question, do you have any sort of official or non-official view on the importance of CCS and blue hydrogen in the fight against climate challenges?
Bellona published a report, it's 19 years ago now, about hydrogen. And what we said there is that Norway has great potential for producing green hydrogen from water electrolysis and blue hydrogen from natural gas reforming with CO2 capture and storage. So I think we are very much in favor of both green and blue hydrogen. And of course, I also have to say that if both Equinor and Shell and the Norwegian government have listened to us 19 years ago, we would have had many gigatons of CO2 savings, and we wouldn't probably not need this webcast discussion right now. But technology is similar to back then, so we can still do it, and it's very good that there's much more momentum for hydrogen now. And I think for that to be in place and to kickstart the hydrogen economy in general, we definitely need lots of big volumes of hydrogen, and for that, blue hydrogen could play a very big role here. And then whether it is in competition or as a complement, I don't know. Both have their merits, and I think it's with advancing technologies and more research, and not least scaling up, actually building large-scale hydrogen production plants. There's going to be cost reductions, and I completely agree with David that the users and consumers of hydrogen also need some serious attention. And I mean, not only because there is lots of different possible applications for hydrogen, but I think since it is, and in particular if you're going to use rather area-intensive production of hydrogen via electrolysis, we need to make sure that we use hydrogen where it is most needed and where it is the most efficient solution. And also that we use hydrogen as a clean burning fuel or reducing agent in industry. And that, for example, means not re-adding carbon to the hydrogen and burn it as a carbon-based fuel, because that just re-emits the CO2 into the atmosphere again. That has something to do with this as an overall climate solution, but also for the legitimacy of the hydrogen economy and for avoiding pumping CO2 into the atmosphere.
Yeah. Thanks, Olav. So you're pointing to some important points there. In particular, you're pointing to the fact that hydrogen should be used when it's sort of no few alternative solutions, and the users of the hydrogen find that as a cost-effective and efficient way of using it. You're also touching upon the user perspective, and one of the things that I would like to sort of understand from you, sort of establishing hydrogen as an energy vector among users means that we need to establish confidence with the user about both the climate solution that the hydrogen represents, and also about, let's say, other factors, including safety. So I guess what I would like to sort of understand is your view on what type of actions the society needs to take or industries needs to take to establish that level of confidence with the broader, let's say, society and with the users in hydrogen as a climate-friendly or a solution as part of the energy transition.
I think Stefania touched upon this already, what is needed to actually reduce the carbon footprint of blue hydrogen production. And I think that not only that the companies monitor methane leaks and do something about that, but also that there is independent monitoring of this to make sure that there actually is a control of this problem, which, as Stefania mentioned, that this rather small changes can have a very big climate impact. I think that also goes for CO2 storage. We need CO2 storage. And I know that Equinor and other oil and gas companies are able to develop and build their own CO2 storage, but there might be more companies and smaller companies than these big oil and gas companies that want to produce blue hydrogen, and they will also need access to a CO2 storage. That would be good for competition. So I think developing CO2 storage is for various users, such as the Northern Lights CCS project that is now being built. That is very important to have more competition and to have innovation in this area.
Mm. Very good. So what I'm hearing is a couple of key points. You pointed to independent monitoring and sort of understanding the safety. So having that transparency with users as an important point. and also being able to provide CO2 storage as a solution beyond sort of those that are developing the storage sites, following the lines of what the Northern Lights is doing, providing storage as a service. We're also seeing other projects like the RMS project in the Netherlands following the same path. So that's inspiring that we're going into that direction. And what I'm also hearing is that we can be able to deliver that type of confidence with the end users. So thank you for your input. Then I promise to let you comment on what Stefania explained to us, David. So I just wanted to get your perspective as well on this issue about the methane leakage. So what do you see as the main challenges of this, and how is Equinor working on tackling this along the full chain from gas production through to the gas and hydrogen use?
So as Stefania showed, the upstream emissions and midstream emissions, so including the plants on land and in Norway, the methane emissions were 0.03%, so it's very low. It's around 1/10 of the industry average. And how was this achieved? So basically, avoiding equipment along the chain that's susceptible to emitting or leaking methane. Installing equipment that recovers methane where what would have been emitted, and then very much on the way we operate our facilities and the whole chain. So one of the challenges is something Olav mentioned. So it's monitoring and detecting. So detecting leaks, if there are any leaks, detecting emissions, and quantifying those emissions. So we have monitoring programs in place, but we're continually working on that front to come up with better technology for better quantification and detection. So that's definitely a front we're working on. Technically, it's possible to have low emissions along a value chain. I think the challenge is to get all the actors in all the regions to invest in those, because it costs more, right? So it's not enough that just Equinor or the NCS is good. If we want to have a global blue hydrogen rollout, we need all of these actors to reduce emissions upstream. So yeah, with the performance that we have, as you can see, we can produce low carbon hydrogen, so hydrogen with a low enough GHG footprint to make real reductions in CO2 relative to natural gas. And then there's one more aspect of this, is when you convert your natural gas to hydrogen, you are avoiding the downstream emissions of methane, so you're cutting the chain. And so the closer you have it to the source, the better, I think. And if you look at our projects, we're looking at Norway, of course, but we're also looking at Northwest Europe and UK. From Norway to those places, we have subsea pipelines which don't have much emissions. So we still have low upstream emissions at those points. Yeah.
Very good. So. Yeah, Equinor is, you're pointing to the need to monitor and understand the emissions and understand where you have those, where you can sort of reduce them. And also the fact that when you're introducing hydrogen production, if you do that close to the source, you will avoid some of those downstream emissions, which is actually accounting for a significant component of the methane emissions. So, Stefania, going back to you as well, is the industry doing enough on this? And I'm not just talking about Equinor. Equinor might be sort of one of the major companies that can boast about their sort of methane emissions from the company. But is the industry doing enough, and are we handling this issue in an adequate way?
Yeah, that's a good question. I think there's always more to be done, to say it like that. Some actors are doing well, others can up their game. And some can up their game significantly. So I think there is quite a lot to be achieved in the area, if we can put it like that. And I think also Olav touched upon a very important aspect, is to have this independent monitoring as well, so that you have this kind of a quality control, not only from the companies themselves, but from an independent actor that can verify the methane emissions.
Seems like we're on the same page on that. I know that you touched upon the sort of issue about the colors of hydrogen, and there's lots of different colors of hydrogen that can contribute to reduce emissions. We talked about blue and green, you can talk about turquoise, you can talk about yellow. So the color might not sort of necessarily be the most important thing to discuss, but I think one of the things that I'd like to sort of get your just comment on is when it comes to the trends that we're seeing for blue and green hydrogen, to some extent they are being directed at sort of different markets. So do you see them playing complementary role, or will there sort of will there also be some level of competition within between them?
I think they should primarily have a complementary role together, that they are targeting kind of different markets, different end user and different scales, especially now when things are kind of getting or taking off. And you might maybe have blue hydrogen as a retrofit, for example, when you're kind of starting up getting things off the ground. There's also a lot of hydrogen production out there that has to be decarbonized, like already existing hydrogen production that is then primarily coming from natural gas and perhaps should be then retrofitted with CCS rather than being completely switched out for green hydrogen production. But I'm thinking in general that these two production methods are important players, and then they complement each other, especially now in this kind of first rollout phase. And I think then if we manage to build out renewable capacity to the extent that we really want to or need to reach our climate targets, that then will be like a gradual, let's say, phasing in of green and phasing out of blue. That should happen in a kind of complementary way.
And I guess, is it fair to say that, I mean, at the scale that we're looking at and developing and the scale that we need in terms of climate solution, we shouldn't sort of go for one option. We need to have, let's say, all tools on the table.
Absolutely, definitely. Okay. We need all the portfolio of things that we can implement.
Very good. So thank you all for sharing your insights and views on the role of blue hydrogen. I'm just going to summarize sort of some of the key points that we've been talking about here. We have a very significant climate challenge ahead of us. There is a certain gap between where we are heading right now with the current policies. All countries need to do more. Yes, there's a lot of countries that have already set net zero targets, representing some 70% of global emissions today, but the actions that are being put forward are not sufficient. Blue hydrogen has a very important role to play, in particular with regards to the hard to electrify and hard to abate sectors, and that's something that we need to develop. CCS and blue hydrogen will be a part of that. There is a need to, like you said, Stefania, decarbonize existing production. When you're producing blue hydrogen today from natural gas, offering that sort of opportunity to decarbonize through CCS is likely a preferred option in many cases. But we also need to understand the greenhouse gas footprint of that hydrogen production, and we need to be able to control that and demonstrate that. But the consensus that I'm hearing from the team is that with the right sort of state-of-the-art CO2 capture technologies, understanding and managing methane emissions, we can easily deliver blue hydrogen as a climate-friendly energy vector. So I'll round off now by giving each of you an opportunity to make a final remark, and I'd like you to focus on sort of a key takeaway that you'd like the listeners to take away from this webcast. And now I'm going to do the opposite order, so I'm going to start with you, Olav.
I think what is necessary is, of course, as I mentioned, CO2 storage and also the right incentives for producing blue hydrogen. In Norway, that could mean, for example, a refund of CO2 tax that you pay when you buy natural gas, and you are refunded when you have actually stored the CO2. I think that would help. And I think it's important, and this goes for both blue and green hydrogen, that we need I think a bit parallel development paths for both the production and the user, as David referred to previously, because we need maybe not a Longship CCS project like the one that we're already building in Norway, but maybe something similar to avoid just having hydrogen ready, for example, steel mills that say that they will use green hydrogen in 2040 or 2050, and then just keep burning gray hydrogen or a natural gas in their steel mills. So that is this type of project. It's complicated, but we need to develop this in parallel.
Very good, thanks, Olav. Next, Stefania, any final remarks? I
think Olav summarized it very, very nicely. And I could just maybe add that the importance of then kind of parallel developing both the supplier and the end user perspective. The end users also will have to have good incentives or good reasons for taking up hydrogen in their processes or in their in their field, comparing to other alternatives out there. So there has to be kind of, the market has to be developed at the same time as the supply has to be developed.
Very good. And then lastly, David, what do you want the listeners to remember after this session?
I think two main takeaways. The first is that blue hydrogen has to be done properly. So we welcome, this focus on the whole chain and the upstream emissions. And then secondly, when it comes to blue and green and turquoise and so on, this feels like a football game where, the goal is clear, coming in well below 2 degrees Celsius. The players know what needs to be done, but we're still arguing about the color of the ball and not just going. So we need policy that supports both green and blue. Both are complementary and needed. Yeah.
Very good. Good points, all of you. So just to wrap up, I'd like to thank our panelists, Olav Øye from Bellona, Stefania Gardarsdottir from SINTEF, and David Grainger from Equinor. Thank you for joining me today. And to all of you listening and for watching this Polytechnic Society webinar on the role of blue hydrogen climate agenda, whether on studio or wherever it suits you. Thank you for listening, and see you again next time.